welcome again, and thank you for joining our global webinar day here at InfoSim. Our topic today is SDN NFV-enabled security architecture for enterprise networks. My name is Dietmar Kneidl, Director of Sales Europe with InfoSim, and I will be your moderator today. Joining us from our headquarter office here in Würzburg, Germany, is my colleague Benedikt Pfaff, who is also a research and development consultant with InfoSim. Bene has worked as a student assistant at the chair of communication networks at the University of Würzburg for almost 2 years before he joined our ranks, and he has a master's degree in computer science. Good afternoon, Bene.
Good afternoon, Dietmar, and hello, everybody.
Also joining us from our office in Würzburg is Klaus Lorenz, who is a security researcher with Genua Limited, which is located in Kirchheim near Munich. His current research aims at building scalable and resilient security technology, leveraging SDN and NFV. Good afternoon to you, Mr. Lorenz. Welcome to the session.
Thank you very much, Mr. Kneidl, and hello, everyone.
Okay, well then, joining us from his office at the TU Munich is Raphael Dorner, a PhD student with the Institute for Communication Networks at TU Munich, where he also received his master's degree. His current research focuses on security in SDN and NFV. Good afternoon to you, Mr. Dorner. Welcome to our show.
Thank you, Mr. Kneidl, and good afternoon to everyone.
And finally, last but not least, we'd like to welcome Dr. Thomas Zinner, joining us from his office at the University of Würzburg. Dr. Zinner studied computer science at the University of Würzburg. He finished his PhD on performance modeling of QoE-aware multipath video transmission in the future internet in 2012. And he's currently heading the Next Generation Networks research group at the chair of communication networks in Würzburg. His main research interest covers network management, SDN, and NFV. Good afternoon to you, Dr. Zinner. Welcome to our webinar.
Thanks a lot for the introduction, Mr. Kneidl, and good afternoon to everybody.
All right. Well, as I've said this morning, we have a pretty good team of experts here with us today. So this is probably going to be a very interesting session again. It's going to be highly technical, so I advise our attendees, our audience, to listen up closely, because we're going to hear a lot of interesting and, well, a bit complicated technical stuff. But before I hand over things, just a couple of household items. First off, as you probably know, when you're joining our audience, you're muted in order to keep down the background noise. So if you have a question you want us to answer, please type it in the GoToWebinar application. And we'll be answering your questions during the webinar, but mainly in the Q&A section at the end. So don't hold back. Let us know if you have a question or a remark. Also, we're recording this event as usual, and you're going to be notified tomorrow with a quick email that includes a link to that recording. Well, that's all the organizational stuff from my end, so I'd like to go ahead, hand over control to our first presenter, which I think is Dr. Zinner, right?
Right.
Okay.
So, before we start with an introduction to the project, I want to highlight the research impact of the SarDiNe project. The relevance of the research questions addressed in the project is shown by a number of publications and talks at high-ranked venues like the Communications Magazine, the Black Hat Conference, or this year's SIGCOMM conference. At the SIGCOMM conference, we showed a demonstrator of the SarDiNe approach, which is discussed in this webinar. The current slide shows some impressions from the demo session. The next slide, please. The talk will feature an introduction to the SarDiNe research project, and afterwards, as already said by Mr. Kneidl, we will go into detail into the techniques and methods used in the project. Can you go to the next slide, please? SarDiNe is a 3-year project funded by the German Ministry of Education and Research within the KMU Innovative Funding Program. The project brings together 4 partners, 2 universities and 2 SMEs. The universities bring in a broad knowledge on recent networking research topics like software-defined networking or network function virtualization, while the SMEs are experts concerning the application domains, namely on perimeter firewalls and security management, that's GENUA, and on network management and monitoring, that's InfoSim. Further, 2 associate partners, the BSI, the Federal Agency for Security and Information Technology, and the Informationstechnikzentrum Bund, which is a major federal IT service company, joined the project and bring in their requirements and use cases. The overall amount of funding for the SarDiNe project is approximately €1 million, resulting in roughly 36 person-months funding per partner. Can we go to the next slide, please? By combining recent technologies like software-defined networking, network function virtualization, and cloud computing, with today's network and security management products, SarDiNe aims at increasing the network security in companies and authorities. 2 key features led to the popularity of SDN and NFV in the first place. Flexibility to run on commodity hardware and easy and extensible implementations of network functions through software-based solutions that indeed can save operational and management costs due to automation. Just as SDN has brought the separation of packet forwarding logic from the routing hardware, NFV goes even further and utilizes software techniques to remove network functions from dedicated network hardware by migrating them to the cloud. The implementation of network functions like firewalls, performance monitors, and load balancers purely in software, as opposed to integration into specialized hardware middle boxes, enables network providers to utilize commodity hardware and cloud computing. This way, the network functions can be implemented in a more cost-effective, flexible, and vendor-independent fashion. Leveraging both concepts, SDN to separate routing and forwarding in the core network, and NFV to implement network functions as cloud solutions, network operators can achieve new levels of flexibility, system agility, as well as elasticity. To achieve the goals of the SarDiNe project, that means to increase the network security, SarDiNe aims at utilizing these technologies for 2 specific use cases. Firstly, a fine-grained isolation between users and services on network level is investigated. This fine-grained access control is achieved by separating the active flows based on the specific user application combination by using software-defined networking. Secondly, a virtualized stateful network firewall is implemented based on the cloud paradigm, allowing scalability and resilience. The next slide, please. And I would like to hand over to Klaas Lorenz.
Yeah, thank you, Tommy. Well, before we dive in the architectural details that Dr. Zinner just mentioned, I would like to outline how in classical network enterprise networks the approach on the architecture is taken typically. Yeah? And you see in this picture, you see the security is typically enforced by a firewall that is placed on the perimeter of the network. If you have multiple network subnets, like a research network and an office network or something like that, then also those networks are separated through this firewall. And any data that flows between networks is checked against the security policy, which can be or is defined and enforced by security management. And inside your private or internal networks, typically have lots of network devices, mostly switches, but could also be routers or similar devices, and also your clients. And all is managed by a network management system, for example, StableNet, which I guess some of you might know. Even further, we see more and more private cloud resources that also are located within enterprises, and these private clouds, they host business applications are useful or crucial for business success. And these clouds again are managed by their own cloud management system. This approach, especially from a security perspective, this approach has some drawbacks, and I'll give you an example. If maybe you recall the WannaCry worm that we had a couple of months ago. Once any attacker is able to circumvent the security measures on the perimeter, for example, if an employee clicks on a bad email down attachment, just an example, and has malware on its machine, then for this malware, it is trivial to spread within the network. So there are no further security measures in place that prevent a successful attacker from further compromising further hosts. And this is clearly not a good standpoint here that we have. The second problem is that the security firewalls are limited in scalability. So if you need more bandwidth, for example, you have to buy more boxes, more middle boxes, specialized firewall appliances. This is sometimes a huge investment in hardware, and secondly, it takes lots of rack space, which is limited as well, and could be used for more business crucial applications, for example. And the third thing is that we see with software, with a switch from classical to software-defined networks. From a functional perspective, it's very nice that you can use virtual networks instead of physically separated networks. But from a security perspective, this is very challenging, because we think, or it is known that over time these virtual networks change, and the large question here is, well, if they change, where is their perimeter? So where do I put my firewall? And to address these challenges, we came up with a more integrated architecture, which we see on the next slide, please. And the main point here is that we have a combined architecture. We use parts that are already there in a new fashion. Mainly the management systems need to cooperate, and we achieve a kind of an omnipresent firewall that runs everywhere. So any network device that we have now is maybe part of this firewall solution, the security solution. And there are two main ideas that I want to sketch out here. The first thing is any client gets its own private network, virtual network. And in this network, it has access just to applications that are allowed by a security policy. And this is enforced by SDN. So if a client wants to access another client, for example, and this other host is not in the same virtual network, which should be the case in most cases, then they cannot communicate. And without this possibility to communicate, a compromised host can just affect other hosts that are within his or its virtual network. And the second thing is any traffic that flows between two virtual networks is checked by a virtual firewall that runs in our private cloud, and every traffic is rerouted to these virtual instances. And by this, we are able to flexible adapt to changes in the virtual network topology, for example. And also, we are able to scale like this. This comes to a cost, as you can guess, and we will see approaches to get along with this later. So, and then next slide, please. Yeah. So now we will get more detailed information on the technologies that we use here. This will be done by Mr. Dorner from the Technical University of Munich.
Yeah, thank you, Klaas. So first, I will talk a little about the fine-grained access control in SDN networks. We heard a lot already about that. We only want to have one private network between one application and one client. Of course, with this approach, we have a very high number of virtual networks, which potentially cause a high management effort. In order to reduce this management effort, we implemented the virtual network creation in a self-service manner. This means the users can access a captive portal and enable just the services they need via this by Bring Your Own Device services website you see on the lower left side. And then the security management and the SDN controller implement just these virtual networks which the user needs. And this reduces and minimizes the attack surface as low as possible, because just the services that the user needs are enabled. Okay, next slide. The resiliency and offloading. So first I go to resiliency. So in legacy clouds, to the next slide, please. Yeah. So what do we need for firewall resiliency? In general, this boils down to 2 points. If one firewall instance fails, we somehow need to get the traffic to a new instance. Usually this is done within 1+1 static protection scheme. And because usually we don't have only stateless firewalls, but we also have state. For example, is one connection open or not? We need to share this state with the backup instance. In legacy, this is realized, the state sharing is realized with a regularly state and keep alive message, and the rerouting is realized using virtual router redundancy protocol, which means the active firewall always broadcasts or answers to ARP requests, and if the backup firewall detects that the main firewall fails, it will take over this ARP answering, and then there will be a rerouting. Because of this reaction mechanism and no real proactive change upon a fail happens, this has some delays. And this is also what we can do better with SDN. So for SDN, we have a slightly different architecture. One point is that as we are in a cloud-based system, we decouple the state from the work. This means that all the firewall instances in the NFV infrastructure report their state always to the state database, and we get rid of these regularly state exchange, and we can also do other protection schemes than just 1+1, or at least much easier, because we don't need any explicit protection configuration because the state is already there. The rerouting is also much easier, as we have already a centralized controller which can then supervise the VNFs, and if one VNF fails, it just changes the control parameters in the SDN network, and then all traffic is rerouted. In the demo, we have realized this via ARP relay. This means if the SDN controller detects that one VNF doesn't report any state or is down, then he changes the routes, and the traffic is rerouted very fast. Another advantage of this approach is that we can do easy scaling, because like a scale down event is now nothing different than a failing event before. If we didn't have this state sharing, this global state database, scaling down would be tedious, because we would have first to move the state again and identify which state has to be moved, and then we could only do the scaling down. Okay. Then the third point is SDN offloading. As we do a lot of firewalling in general in our architecture, we will have very high load on the virtual firewalls. In order to relieve this a little, we are using the SDN hardware to take over some of the tasks of the firewall. In general, this is done by combining the strength of NFV and SDN. One strength of SDN definitely is traffic steering. And if we imagine that we only have stateless checking of the packets, SDN hardware would be fully enough. But if we want to do more, like for example, stateful checking, we need software, because usually the SDN control plane can't handle all of these events right now. So what we do is that we do first the connection interaction. The first connection setup is done via the virtual firewall, via software. And then if the connection is established and the firewall says, okay, everything is fine, we are doing offload and just use the hardware, which is depicted in the picture with 2. And this reduces the load to the VNF. How is this realized in the demo? So what do we need? Of course, we need the VNF. We need the optimizer, which decides, okay, now we are doing hardware acceleration. The optimizer triggers the SDN controller, which then programs the data plane. In the demo, we are using NetFilter firewall as VNF, only a dummy optimizer, and an honest SDN controller. As you can see, NetFilter is using contract to export the state, and REST calls to the honest SDN controller, which is then using OpenFlow control to program the Open vSwitch. Open vSwitch is a software switch, but in general, OpenFlow can also be used for real hardware, and with this approach, we can easily also apply our approach to hardware networks. Okay, so this was from my part, and then Benedikt will show how our system integrates with InfoSim's StableNet software.
Yeah, thank you, Raphael. Now we'll continue. And again, hello to everyone. So my part will be now to demonstrate how StableNet is used to manage SDN, NFV, and cloud setups, especially for the demo we had at the SIGCOMM. And yeah, we'll shortly also go over the use cases Raphael just mentioned, which were the fine granular access control, the offloading, and the resiliency of Firewall. So this slide right now gives you an overview of what we are currently monitoring with StableNet in our demo. So we have a StableNet instance running in the demo, and we monitor, of course, the SDN controller, which is in our case the Honors SDN controller. We monitor the cloud itself, which is an OpenStack cloud. We monitor cloud and network services, which are, for example, an email service, or in our case, an IPCAM service, which I will show in the next slide. We monitor the access control. Since our use case is to bring your own device, this is pretty interesting from a monitoring point of view. And then we monitor, last but not least, our virtual network functions, the VNFs, the firewalls, like you can see here. Okay, so now you see the StableNet GUI running in our demo, and I will now go over all the parts I just mentioned. The first thing is the network services, which you can see here. So the Honors controller provides us with all the information we need to know about the services that are currently running within our setup or within our network. And for example, you can see here an email service, an IPCAM service, and print service, and so on. The service itself is represented in StableNet as a device with a status, and right now all the statuses are green, meaning that every service is up and running and the status is okay. So the next thing you can see is the access control. So right now we have normally should have a list of users. For our use case, it's just one user. For example, let's say, okay, it's a tablet with the MAC address beginning with 94. And for each of those devices, we have measurements in the number of services that are currently available in the network, or the user is allowed to access. So in our case, since we have the admin tablet, there are 4 measurements, and those 4 measurements belong to the 4 services we have. For example, the email, internet, IPCAM, and print. So the status of the measurement has the meaning or represents the current connection to a service, meaning that the green OK alarm for the IPCAM service means that the user has right now a connection to exactly this service. So the next thing I want to show is the SDN controller monitoring. Here you can see the Honors instance, and its status is okay, meaning that the controller is running up and everything is fine. So the next thing is the virtual networking functions. You see on the left-hand side the 2 firewall instances, the VNF1 and VNF2. Both are okay and the statuses are fine. And on the right-hand side in our weather map, we can see which of both of the instances is active right now, and you can see that by the bandwidth line, which is a bit thicker than the other one, meaning that the bandwidth is greater, and this means obviously that the VNF2 is now active, and all the traffic, in our case from the tablet to the IPCAM, is forwarded through the VNF2. So next thing I want to show is the resiliency. What now happens is that one of the firewalls break, and you can see that on the left-hand side, the status switched to a major alarm, meaning that something is not going well with the instance. And what happens next is that we see the same behavior on the weather map on the right-hand side. The lower link dies, and immediately the firewall 1 will take over, and the bandwidth is now going, or the traffic is now routed through this firewall. In this case, the user won't recognize this, since it's all done in the background, and in our case, we demonstrated normally with the IPCAM stream, you won't see any changes in the stream. So, and the last thing I want to show is the firewall offloading, which we can also see in the weather map. In this case, since the offloading is already in place, there's no traffic routed over any of the firewall instances, meaning that there is the bandwidth is almost zero. To have this, to have a better view of this, I want to switch now to the Honors SDN controller dashboard, which can be seen here. To get a better understanding of what happens during the offloading, so at least from our perspective. Here you can see the dashboard, and the user on the left-hand side with the IP 142 at the end is right now connected to the service with the IP 4.201 on the bottom. And right now, the traffic between the mobile phone and or the user and the IP cam is rerouted through the cloud, through the firewalls, and then goes to the IP cam and the other way around, like you can see on the bottom right. So what now happens when the offloading is in place is following. The traffic is not routed anymore through the cloud, but is directly routed to the IP camera, which you can see right now here. Yeah, that's in fact what we intended to show for this webinar, and then thank you for your patience, and I give back to Dietmar.
Back to Dietmar. Thank you very much, Bine. I have uploaded the PDF version of the slides we've used for today's webinar in the meantime, so if you're interested in that, please look at your GoToWebinar application. Should be available for download. File name is GWD 2015-09-28 final PDF. Okay, I got a couple of questions. I think question number one is targeted for the general part, or the firewall part. So one of our audience members wanted to know if the firewall instances scale, so if you can use that in like a bigger, larger environment. Don't know who's going to answer that.
Yeah, I will. So yes, they can. But we did not implement that yet. If you recall, we run them in a cloud-like environment and as virtual firewall instances, and like this we can easily scale out. And also with our rerouting mechanisms, this is also due to the SDN. This is also possible to support the scaling. Okay, so it could be done. It's just you haven't done it for the sake of the project. Okay, good. Another question I think is more directed into Bine's direction. Bine, one of our audience members wanted to know what else we monitor for a user, or what else we can monitor for a user, or if it's just the connection to the service.
Okay, thanks for the question. Basically, we can monitor everything the controller API provides us. But for the approach, for this approach, we started with the user to service connections. But I think as a next step for this project, we will focus also on monitoring byte counter and bandwidth and stuff like that. So yeah, this is about to come. Okay.
Excellent. I think that answers that question. And the final question I hear is something that is more of a global interest. One of our audience members wanted to know if there is a possibility to join these research activities, and what would be like kind of the first step if he or his company wanted to put up a setup like you have just described in his network or in his test lab. I'm not sure who's going to answer that. I think Klaus probably.
Yeah, sure. So answer to the first question, yes, we are very open to have input or also help, or like maybe you are interested at seeing the demo yourself. it's a little bit more impressive if you see it live. I can guarantee that. So, and the first step to kind of join us is, well, send us an email or call us, or if you have any other communication channel to one of us, you could join. You can use that. Also, we have a website. I think it's on slide number 6, SarDiNe-project.org, and there we also have our email addresses, for example. And I think this is the first step, and then, well, it's kind of depends on what you're interested at, and how we see possibilities for cooperation, with which I'm very hopeful that we will find an interesting way that works for all of us.
Okay, well, thank you very much. That very surely answered that question. Well, I guess that's the end of our session today. We have overstepped our time limit by a couple of minutes. Apologize for that. We're pretty sure it's all Bena's fault. Of course, we have more information on our website to other StableNet related topics. So feel free to visit us and dive into our resource section. And well, thanks for all our participants for the session, and thanks everyone for joining us today. As I mentioned earlier, a recording of the webinar is going to be available tomorrow. You get a quick email, and well, I guess that's all from us now. Any final words from our presenters?
I would like to take the opportunity to say thank you for having the possibility to give a webinar on our research project. So thanks a lot, Mr. Kneidl.
You're most
thanks
welcome.
a lot for attending.
Okay.
I agree on that.
Well, I'm glad we all agree on that. All right. Well, that's all from us today. So thanks for joining us, and enjoy the rest of your day. Goodbye.